All right, everyone, how's it going? Today we will go over um, the first lesson that will lead us to graphing trig functions. So we will talk about something called periodic behavior. So if you noticed like when you think about graphing sine and cosine, you may have noticed that like the wave that it makes can go on forever, because if you think about the terminal arm swinging around the axis, right? Um, if I look here, right, if I have this terminal arm, it can swing like an infinite number of times, which means that the wave of a sine graph or a cosine graph can go on forever. And the shape of the graph has a repeating pattern. So that's what we call a function, trig functions periodic. So over here, we just have a little disclaimer, right, that the graph repeats at regular intervals, all right? And then the y values repeat at regular intervals. So that's more of just a specific restriction there, where like I could have a pattern that repeats, but like it could move in different sections of the graph. But for a periodic function, the graph has a repeated pattern, but then the y values also repeat on regular intervals. Okay, so we have some definitions here to go through. So a function that describes periodic data can be described as, try to say this word before I say it, it looks weird, sinusoidal. So you, like in the textbook, or if we were in a regular class and we would be discussing this kind of stuff and I would be talking about it, I may refer to trig functions like sine and cosine as sinusoidal, okay? So a cycle is just one pattern, okay? And the period is the horizontal distance of one pattern or a cycle, okay? So we will be using, in terms of like the new terminology that we're talking about, okay, like we'll be using the term period for the length of a pattern, okay? So if I look here, right, obviously if we look at how we define a function, a graph repeats at regular intervals and the y values repeat at regular intervals. So yeah, like the y values repeat here, here, and here. It's not going bigger or smaller. And then same thing down there, down, right? I have the y values are repeating. And then in terms of like looking at it, you're like, well, okay, like obviously I can see a pattern and it doesn't really matter where I start. If I start up here and then just follow this pattern, tell me when to stop. And then once I get up here, that is now one pattern, right? And if I move it here, it's the same pattern. So it has, and it's the same length too, right? So again, if we talk about what the period is for this particular one, right? You say, well, okay, what's the length of one pattern? Well, here I started at 1, and then I ended at 6, right? So the period is, I mean, if you need to do 6 minus 1, you can, or it's 5 units, right? 1, 2, 3, 4, 5. Okay. And just to kind of reiterate, it doesn't really matter where I start. Like I could have started down here and then color in this, trace this until I start repeating, right? And then you get hit here. So like that length is still 5, right? It goes from 0 to 5, all right? So hopefully that's not too messed up or confusing. Next is some more definition. Oh, sorry, examples first. Okay, so let's determine whether the function is periodic, and if so, state the period. So if I look at this, Hopefully, like, do I have repeating y values? Well, yeah, like this thing is like stuck between looks like 10 and -10, right? And does it have a repeating pattern? Well, yeah, like it goes from here up, does this, goes down to 1, and then it does this, go down, and to 2. So yeah, it's periodic, and the period is 2. Oh, sorry. I meant 1. Okay. This one here is not periodic. Why? Well, like, check it out. Like, the shape looks like the pattern looks kind of similar, but it's increasing, it's rising. Okay. So again, if we want to just say like y, right? It does not have repeating y values. All right, everybody cool with that? Right, so again, this one, periodic, this one, not so. Okay, well, that was easy, hopefully. Now let's get to some more definitions. Okay, so here, so I have something that we call an amplitude. Okay, so if you took, I'm pretty sure in some science class, I think if in physics, I'm pretty sure you probably have heard of amplitude. So it's just half the difference between the max value of the function and the min value. Okay, so max minus min divided by 2, right? That is my amplitude. Okay, notice, right, if you look, right, this a value, have you seen that a value before? Yeah, right? If you remember in graphing, the a value dealt with like a vertical stretch or compression, right? So it would make sense that in the future, when we start graphing trig functions and transforming them, that amplitude is going to have the same effect as it did on other functions where I had an a value, okay? Axis of the curve is a horizontal line that is halfway between the max and the min value, okay? So that's hopefully, like, you know, when you think about it, you're like, okay, like halfway between, well, what's, if a number, you know, if I have a max value and then a min value, how do I find out the middle, right? Well, if I add them together and divide by 2, okay? And then phase shift is the horizontal shift of a graph from its original position. Okay, so this we've done before, and it depends on the original graph. And this is like where phase shifts are a little different in trig functions, because as I said at the start, trig functions, the waves can go on forever, okay? So if I look down here, first off, if I ask you what type of function this is, I could get multiple answers, right? Like, so if you start here and go up and then down and then back up, right? You'd say, well, what is this? This is a, think about it. I'll give you like 5 seconds. If you don't know, probably you need less time, right? This is definitely a sine graph, right? The hell is that? Sorry. Sine, oh man, you guys know, you know what I mean, right? That's a sine graph, okay? However, maybe you pick this. You say like, yo, what if I draw this? All right, and now this blue graph, what is this blue graph? Well, this blue graph is a cosine graph, okay? Whereas the purple one is a sine graph. So you'll notice that, like, I can have, like, for example, this one wave that you're looking at can be represented by a sign and a cosine graph. But we'll get into that more later. So let's get rid of this for now and just answer the question. Or let's talk about amplitude. Okay, so if I go up here, the amplitude is half the difference between the max value and the min value. So if I look here, okay, if I look at my like this function has a max value of 1 and a min value of -1, right? So if I want to, like, we're looking at it, obviously you say, well, what's half the difference between the max and the min? Well, what's the difference between the max and the min? 1 minus -1 is actually 1 plus 1, which is 2. 2 divided by 2 is 1. So like the amplitude, if I can color this, like this value here, this is the actual amplitude. All right, and I can color it in just to emphasize that, right? Like the distance from the x-axis to the max, right? Like what is the distance of this hill here? From the x-axis to the max is 1. What about the distance from the x-axis to the lowest point? Well, that is also 1. Okay. Right, so again, my amplitude is 1. Okay. My amplitude is 1. All right. The axis of the curve, if we go back up here, is just a horizontal line that is halfway between the max and the min. So for this trig function that it hasn't been changed at all, what's the axis of the curve? Well, the axis of the curve is the x-axis, okay? So the same distance from the axis of the curve to the max, 1 and -1, all right? And then in terms of a phase shift, well, this one, right, this is kind of what I was saying before, right? Here, a phase shift, right? Well, if I'm looking at this using sine, there is no shift, no phase shift. But if I have cosine, there is a phase shift. What was the sine cosine phase shift? Cosine started here and went down and up like that. So that would be a shift of 90 degrees in the positive direction, okay? But we'll get into that more as we progress through stuff like during our last week of trig, okay? So let's just do all that now. So here I have a picture. I have a trig function. So like here, oh, let's go, come on. Oh, geez, sorry. So I have like make a line here. So my max is at y is 10, right? And then my min at y is 2, okay? So if we just, let me just scroll up here for a second, right? We want to highlight one cycle. So again, you can highlight really the cycle at any point, okay? So like what I'll do is I will just highlight the cycle from here, right? So I start at 0, and then I go up, and then I stop right here. So what cycle did I just color? I colored in a sine. Okay, everybody see that, hopefully? So now the axis of the curve. Well, we know the axis of the curve right, is halfway between the max and min, right? So here you can see it hopefully relatively easily. We say, well, okay, what is if I start at 2 and go to 10, right? What's the gap, right, between them? You can look at on the graph, or remember I had like that equation where I said like max plus min divided by 2, right? So that's 12 over 2, which is 6. So this 6 is the axis of the curve. And that makes sense because if you look, like, where does sine start? Sine starts right there, right? And in terms of my key points, I got to keep, like, I have a key point here, got a key point there, got a key point there, a key point there, and a key point there. Okay? So my axis of the curve is the line y equals 6. All right? Now, what is the amplitude? Now, remember, the amplitude you can calculate, but remember, like when I colored it in, I said, well, okay, like, so my axis of the curve, notice how now also, I guess I can say, my axis of the curve isn't always at the x-axis, right? The last graph we looked at, my axis of the curve was down here. Now, obviously, this graph has been shifted up. So like this part I'm coloring is the length of the amplitude, right? The distance from the axis of the curve to the max, and then the distance from the axis of the curve to the min, right? So here, right, this is my amplitude. This is my amplitude, and they should be the same, right? What's the distance from 6 to 10? Well, that's 4. And then the distance from 2 to 6, right? That's 4 as well. Okay. What's my amplitude? Ready? 4. Yeah. Okay. Good. Hopefully you got that, right? Right. So my amplitude, or my a value, is 4. Now, what's the period of this function? Well, let's just calculate. I start here and I end at 4. So the period is 4. Okay. Everybody cool with that? Yeah. Okay. So let's just take a break, and then we will come back and complete the rest of the note. All right. I'll see you in a bit.